Okay, the question says what's happening up here. P collides with Q and then Q collides with R. In the second collision, Q and R coalesce and subsequently move with a velocity of 1 meter per second. Find the speed of Q immediately before the second collision. So I need to just look at Q and R. And Q is 0.3 mass and this is 0.6. It starts off here. This one I've got to find U, and that one is 0.8, and they go at the same speed afterwards, and the speed is 1. So both of these go at 1, and I know that total initial momentum equals the total final momentum. Momentum is mass times velocity, so everything's positive. I know direction matters, but everything's positive here. So mass 0.3 times by U plus 0.6 times by 0.8 equals the final momentum 0.3 times 1 plus 0.6 times 1, and that will say that's 0.3 U equals, that comes to 0.42, and so U equals 1.4. So that's now worked out that. Now I've got to work out the change of momentum of P, so I need to look at the collision between P and Q. So that's P, that's Q, so 0.1, 0.3, and I know the final speed of this one is now 1.4. I know its initial is 1.1 in that direction. This one I've got absolutely no idea with. I got the V for the final of this, and this one I'm told starts at 1.5. Yet again, total initial momentum equals total final momentum. So mass 0.1 times by 1.5 plus 0.3 times by 1.1 equals 0.1 V plus 0.3 times 1.4. So on the left hand side I've got 0.48 equals 0.1 V plus 0.42. So 0.1 V equals 0.06. So V equals 0.6 meters per second. But that's not what he wants. He wants to change in momentum. And so change in momentum equals the final momentum minus the initial momentum. The final momentum is the mass, which is 0.1 times by the final velocity, 0.6, minus the mass, 0.1, times by the initial velocity, which is 1.5, and that equals negative 0.09. And that's, if you want to put units down this, kilograms mass times velocity meters per second. So it actually loses momentum. And that's question 1 done.